Hi, everyone. Welcome to Conveyor Meetup. Today we have Bill Bensing, who will be going over Red Hat Trusted Software Supply Chain. Cool. And, we're super excited because this is the first time we're covering DevSecOps at all. And we really don't have any big announcements other than if you're not already part of the Google group, I'll be putting the link in the chat so you can sign up through there. And this is just a way for you to get invites to future meetups and also get announcements on any of the or updates on any of the open source tools we have. So, Bill, it's all yours.
Awesome. Thank you very much. All right, let's go ahead and get sharing here a little bit. All right, everybody. Thanks for the opportunity today to come on and talk about this. Run through some slides and a bit of a demo, but at a high level, sort of what we'll discuss. We'll talk about me for a second. Who is Bill Bensing? And I want to go into some aspects of the flow framework. So if anybody's read the book From Project to Product, steal some stuff from Kirsten from there and talk about around the trusted software supply chain. But we'll go in and just start discussing the trusted software supply chain problem. I'm looking at tool versus workflow first approaches. And then let's just talk about how the trusted software supply chain operates. This is a unique approach looking at how to bring DevSecOps and sort of DevOps in a consolidated, centralized approach into an organization. So who is Bill Bensing? Of course, that's myself. But really, my whole goal and sort of the reason why I've taken on this role here at Red Hat, about 6-7 months new, is I like to give everybody the opportunity to build software at any time. My bit of my background is within Fortune 50, Fortune 100 companies, some smaller companies as well, but a lot of it's been around legitimizing shadow IT. And what do I mean by that? I didn't start out as a classically trained software engineer, so I didn't come out of college from a CS degree and into a software engineering approach or a software engineering organization. I came out from the business aspect, and I was a hobby coder. And so I started building software inside of some of these companies and took that to the next level in a career. And what I realized is it's very hard, and sometimes rightfully so, to get software moving inside of an organization. Now, this is 10 or so years ago, and at the beginning of the discussion of cloud and cloud in the enterprise. Nowadays, we're talking about Kubernetes, moving to Kubernetes. The whole concept of legitimizing shadow IT and or aligning for business value is just really what it is. That's how tech companies operate. So a lot of my history is going through and just legitimizing shadow IT and bringing folks together through the business and the IT realms and saying, okay, how can we do this bigger and better and let anybody try to bring a piece of software to production or bring a piece of value to production. Through that career, I've been in and out of industry, jumping in, helping companies, and also jumping out to my own startups and other startups that I've helped bring to market. And so a couple is on the right-hand side. But outside of that, today I want to discuss first, before we get into TSSC, about the flow framework. And what I like about the flow framework, and sort of Dr. Mick Kirsten, who brought this to bear, he has this very poignant approach. I think everybody understands this, but to read off the slide, yes, as startups disrupt, every market and tech giants pull further ahead of entrenched businesses. The majority of enterprise IT organizations are facing an existential crisis. That's very true. A lot of what I see, a lot of working with, is to help prevent that existential crisis. Either they work quickly to become much better at software, or they risk becoming a digital relic. You think about Conveyor and what Conveyor tries to promote. That's the whole idea. Is if you're moving to Kubernetes based upon Borg, and Borg was this way that Google brought about sort of autonomous software delivery inside of Google. You are trying to figure out how to represent those underlying human processes with technology. So really what it comes down to is being better at software. And this is why I like the flow framework, because while I'm not going to read through this, what the flow framework does and the perspective it brings is how you master large-scale software delivery software delivery in an organization. Now, Dr. Mick Kirsten will go through, he talks about value stream networks, looking at it from a pipeline to a network approach. But the idea is having an organization come to bear and say, what is our rationalized, unified approach to how we do software delivery? And why this is key and where this plays in with the trusted software supply chain is the trusted software supply chain itself is trying to do this. The trusted software supply chain is trying to bring a unified, opinionated approach to how an organization can achieve this. So IBM's done this with like the rational unified process, and then Google's, Facebook's of the world, they've built out centralized unified approaches to deliver. And the idea is, how do you get business value to a customer? So as we go through and talk a bit today about the trusted software supply chain, a bit of a perspective I just want to challenge folks to keep. Software delivery is not linear. It is a network. A couple things we've mapped to, and we'll go through and talk about these at the end, is as we think about what Dr. Mick Kirsten's talked about in the flow framework, he talks about tool networks, artifact networks, and value stream networks, mapping a couple of the trusted software supply chain components to this to help demonstrate how you can use the trusted software supply chain to help build that unified approach inside of your organization or other organizations you're helping with. So the TSSC problem. So why a trusted software supply chain? Think about change management. The whole concept of change management is to enforce a change or a behavior change. And that's where the trusted software supply chain comes from in philosophy. You want to enable, accelerate, and enforce those processes and expected behaviors for software development and deployment to build a DevSecOps culture. Now, why DevSecOps as opposed to DevOps? The idea here is you're looking at that unified approach, so bringing in more of the organization, say, how do we do this, including security aspects as a first-class concern, so you can get things such as trust and establish trust. Now, trust is critical because it's more than security. It's compliance, it's transparency, and it's privacy. So what do we mean when we say these four aspects? Security is the system. You want to make sure the system runs the way it should, protected from any internal and external adversary. We know that a lot of us focus on security. Compliance may be somewhere where a lot of us do or don't focus depending upon your industry, but you're just making sure your system meets regulatory requirements. Now, these could be government's requirements, could be local state requirements, could be some nation states requirements, or it could be other type of industry requirements in themselves. Transparency, now this is key. When people start to put together things like CI/CD pipeline, how many times can you look in the system state, that pipeline state, and see if it's observable and actionable? This is a key component of a trusted software supply chain, as well as privacy, keeping your secrets secret. How many folks know that a Git repo where there's plain text passwords inside that Git repo that are being used for deploy or runtime? The idea behind the trusted software supply chain is to look at this unified approach. It's not just a CI/CD pipeline, but it's everything that has a concern from ideation to production. And how do you bring that in? How do you bring that together in a unified approach? So as we think about the answers the questions we want to answer with a trusted software supply chain, it is, what exactly is my DevOps workflow? What specific DevSecOps tools should I use? And how do I scale this inside of an organization? And as we try to answer these questions, what you find out is before you have a trusted software supply chain, a lot of folks' CI/CD approach is hurry up and wait. Yes, they've got a Jenkins or they've got some type of CI/CD or orchestration tool in there, maybe at some level of automated scanning, but a lot of it is a hurry up and wait and stopping for a manual security review or manual acceptance testing. And then auditable CI/CD data from an automated governance perspective, some of that can be questionable at best. Now, these issues you see here, they're unevenly enforced processes, and you have misunderstood expectations of behavior. So that's why it's hard to establish trust in this sort of hurry up and wait model. Folks like to think that this is quote unquote more secure and more viable for the organization, but it has the opposite effect. By reducing time to market, reduces the amount of backlog. People try to put things into try to put bigger changes into production. You have larger vectors for failure, i.e. you get into a lot of those issues where you're constantly failing to push to production. But with a trusted software supply chain, what you want to do is you want to realize this capability securely and fast. You automate all aspects of this. Now, it's easier said than done, and I understand that. But the concept as we go through and we'll talk today is really how do you automate this into automating even the collection of pipeline data. Now, when you do this, you define and you enforce those processes and those expected behaviors. You're putting a physical medium in place that says, here's how you behave, here's the expectations, and here's how you deliver to it. And this is great because it can easily establish trust by having security and compliance automatically applied. Security as code and or compliance as code. That it drives transparency and privacy as a first-class citizen. And that's important for our next topic because let's talk about workflow first versus tool first type approaches. When people think about building a CI/CD pipeline, and I asked them, what's your workflow? when in doubt, almost 99% of people come back and be like, all right, I started GitHub, and then GitHub has a hook into, or Jenkins has a hook into GitHub. And then that goes into SonarQube, and then therefore to a set of tools. That's a tool-first approach. By taking an approach and a perspective like that, what you do is you limit your capability to grow over time and to establish trust based upon the competencies and capabilities of those individual tools. And so if those tools are, if there's a bottleneck of one of those tools in that tool chain that prevents you from establishing trust, that means you can't establish trust in your pipeline no matter how many other tools you put in there. So that's why you want to start with a workflow first approach, looking at what are the, and I'll use the word business architecture if anybody's a TOGAF and from the EA background. You start with that business architecture, irrespective of technology and implementation. What are those policies, the processes, the workflow that we need to implement, that the tools need to implement so we can achieve a level of high trust? Now, by doing this, we tend to ask ourselves 4 questions as you adopt a trusted software supply chain. I grabbed these 4 questions from Beyond the Goal by Dr. Eliyahu Goldratt. If you've read the book The Goal, or if you read the book The Phoenix Project is an homage to The Goal. The Goal talks about a theory of constraints, but also what The Goal does talk about, and Dr. Eliyahu talks about this in his audio series Beyond the Goal, is you have 4 questions to adopt a piece of technology. What's its power? What limitations does it diminish? What are the old rules it operates by? And what the new rules you must operate by? Now, these last 2 questions are very important because if you adopt a piece of technology and you don't swap your old rules to your new rules, you don't swap in for the new rules, then that piece of technology may not take you where you need to go. He gives some simple examples about MRP systems in the 70s. And if you're familiar with the 60s and 70s, and if you're familiar with MRP systems, at a high level, it's a bunch of dependent calculations. So there used to be a group of people who would sit and take about a week to 2 weeks to do all these calculations and figure out what they need to order to keep in stock. And they probably have roughly 2 months of inventory in stock. Now, having 2 months of inventory in stock, that's a lot of parts to buy. If you could reduce that to something like a week, then you have a lot of capital left over for other investments to grow the business. So what MRP systems did is they automated all those calculations, took it down to a couple hours to calculate. So then the old rules where you'd order on basically a monthly to 2 month basis was surpassed by a new rule where you could order on a weekly basis. Companies like Black & Decker did this really well, and so Black & Decker became a low-cost leader, and other companies who tried to do this, the MRP, they didn't achieve it. Black & Decker adopted that new rule along with the MRP technology, but other companies, they adopted the MRP technology but didn't abide by the rule, so their cost of execution actually went up. So as you think about, and we talked through today, going through something like a trusted software supply chain, its power is to achieve that high speed to market and trust simultaneously. It diminishes those limitations of manual checks that decrease the time to market and also increase the probability for failure. Those old rules, though, now this is very important. Those old rules are having domain-specific people manually verify aspects of trust, whether it's security, functionality, whatever it may be. Those are the old rules. The new rules, you have those domain-specific people codify those aspects of trust, and the automation, the trusted software supply chain, implements that codification. So it is compliance as code, security as code, and that's the key change in thinking as we talk about the trusted software supply chain. So how does the trusted software supply chain work? It's a lot more than technology and a tool. It is a set of 3 things: a workflow, a standardized, recommended, and opinionated workflow for a CI/CD approach, a prescribed set of tools and services, and a piece of glue. And we'll throw this glue more specific in the near future. But the glue is really the core value proposition that doesn't exist out there in industry and allows us to help build a unified approach for an organization. So the workflow, standard steps and processes. The idea is all aspects of trust are automated, bring security as far left as possible, make things like security, auditing, and traceability a first-class citizen. So what does this workflow look like? High level, here's what it is. This isn't anything astounding, and I know that, but the concept is if you look at this, almost all types of idea to production workflows will look like this at the highest levels, which is good, because as you introduce something like the trusted software supply chain, you want to bring the right change. You just don't want to dump everything on top of its head and try to do something new. So where does this get very specific? It gets into the steps, and I'll show you those steps here. We'll go to a full DevSecOps workflow, which we call the standard. As you go into this, what you're going to see here is you're going to see now all these little, these steps and how they feed into each other. First off, as you look at the workflow, it's not just talking about GitHub. You'll notice no tool, no specific technology is talked about in here. We talk about an abstractions of components such as source control tool, not Git, GitHub, or whatever, or whether source controller may be. But as you look at the workflow, we talk about security first. The idea is setting up encryption standards to begin with. So setting up PGP keys to encrypt and decrypt any types of secrets you may have, making privacy a first-class citizen. Then we go down and we talk a bit about metadata. Before we even kick things off, we start generating metadata about commits and about the pipeline itself. Why? So you can trace everything through and you have provenance, you have visibility into what happened at any specific point in time, which brings into automated governance and the capability to easily audit. As you see here, these little yellow lines, we go to the bottom, there's a generate and publish workflow data report. The aspect behind this is now we've up-leveled the conversation around CI/CD to a true unified process. If you look at everything and the concerns that are being addressed in this workflow, security, auditing, it's more than just, continuous. It's more than just, looking at did I meet some figure for code scanning, or did I meet some compliance, which those are important, but it means there's a lot more to it from a trusted software supply chain perspective. I'll pass the links to you all at the very end so you can look at these things. We won't dig into it deep, but I just wanted to show you through, let me talk through a workflow. This is what it means to be workflow first and not tool first. This is what it shows you, and this is how an organization can think and plan to ensure they have the capability to future-proof their approach for CI/CD and grow over time. And a couple high-level things that we just covered in there. Trust is knowledge. So establishing trust is generating that data and having auditable provenance over time. We do that as some of the first steps in here. The ability to have the same workflow with different tools. Notice, we can have the same workflow here, literally the same abstraction of workflow, the same policy and expectations, but we can use different tools in here. So you can have two different teams, one using Java and one using JavaScript, and they can share maybe a common service such as SonarQube. And you have the same workflow applied to everybody, and everybody knows the expectations. If you need to swap tools, you can do easily. We'll talk about the glue. It brings in a plugin architecture for these tools. But say you want to go Fortify over SonarQube, the ability to swap it out is a key component here, based upon whatever the economics or the need at that time for that tool, or if that tool just becomes irrelevant over time. Automated governance, one thing we do want to point out here as we're going towards automated governance, the ability we talk about auditing. So taking those scopes around security compliance and putting things as code, and then having a workflow and a capability to validate that, to establish attestations and attest that this software artifact is good for deployment. That's where we get into here from a unified workflow. That's what we try to make very prevalent inside of something like the trusted software supply chain. Services and tools, I do have a list of these. I'm going to scan through and point out some critical ones pretty quickly, but what I want to talk about around tools and components is it's identifying not specifically the underlying tech, but those types of classifications of tools. The idea here is you get to production with 100% trust, and it's, a lot of this is quality at the earliest step. Some of the things that we built out trusted software supply chain to be is based upon Kubernetes, and specifically right now on OpenShift. And it brings in some of the Red Hat single sign-on capabilities, especially around key cloaks. So you can proxy your identity management and/or have a identity management approach for your trusted software supply chain. A couple things I'm going to show here: source components, recommended and alternative apps. The ability, and we'll talk about the upstream project Plygos. But any app can be used, and that's where a contribution the upstream comes in, where folks can contribute what we refer to as step implementer to implement an underlying specific tool. But at the end of the day, it's not limited to specific tools. It can be grown over time. So the community is there. So there's a community that can provide tool sets for each other. CI/CD. Right now we are focused on Jenkins, but we do want to grow out as Tecton, and as Tecton becomes the more preferred solution inside of Kubernetes, growing up to Tecton and Argo. So it has a bit more of a Kubernetes-based approach. And the advantage of having this deployed on something like Kubernetes and OpenShift is you now not just standardize workflow, you can standardize the underlying technology that delivers your software to production. And production could be an embedded device, and production could be a container runtime or a non-containerized runtime. And production could be just a repository storing a virtual machine or a container image. If you think about those types of deployment targets, standardizing your workflow and the underlying technology If something like with something like Kubernetes allows you to have very minute targets and allows you to have not just flexibility, but the overall ease of maintenance as well as around interoperability. Some things around here, build test, we'll show you as multiple languages, a couple things around using build and Scopio, not using Docker, going to more of the OCI as opposed to Docker just because of the root issues necessary for things like Docker containers to run. SonarQube, you can see here, alternative apps. Interesting one to point out is configuring from a validate environment configuration. As we think about quality, quality is not just the software quality, is it functionally and security, but think about deployment. If your deployment manifest is messed up, if there's something that's not in there or something that needs to be there, and you try to deploy it and it's usable or hardly usable, that's a quality aspect to a customer. So as you look through that unified process in your workflow approach, what are all those aspects that define quality? And things like configurant and validate environment configurations can prevent a piece of software going to production or going to the customer if it doesn't have something such as a validated deployment config. Now let's talk about our glue here. The glue is the fun part. This is where a lot of concepts we're going to talk about here in shortly. We talk about the flow frameworks, things like software factories come into play. It allows us to future-proof the pipeline. It brings a declarative CI/CD configuration with a limited domain-specific language, and it brings a self-service capability. It allows you to hide the complexity of not just the workflow, but brings in a push-button approach for an organization. And helps us instantiate this concept of a software factory. So I will show a couple demos here around this, and we'll spin this up from scratch. But the idea here is you can go into something like Operator Hub, and you'll see the software factory, and it can be curtailed for your organization, but you click on it, and once you click on that, you can install a platform and a pipeline. And we'll dig deeper into what a platform and a pipeline is, but at a high level, a platform is just a set of tools that have been integrated together that can be used for a CI/CD or a trusted software supply chain. And the pipeline itself is that workflow overlaid on the set of tools on how you deliver specific types of values. Is it a container? Is it a VM? Is it a containerized app? Is it an embedded app? Whatever it may be, that's what a pipeline represents. So I'm going to go ahead and kick a demo off here real quick and show you how to get started with it. So if you're interested in doing this in your own OpenShift cluster, you can go to Plygos, github.com/Plygos, P-L-O-I-G-O-S. Click on the software factory operator. That's the biggest operator, and here you'll see the directions on how to get started with doing this. I followed a couple directions just to get this up and going, such as bringing the operator catalog source, and then putting in a new project called DevSecOps. Let's go switch over and look at this real quick. So I've got this project called DevSecOps. I'm going to go down to my installed operators, with my operator hub, and let's just quickly install the software factory operator. There we go. I'm going to go ahead and install this into the DevSecOps namespace, so all my tools and things will be in there. We'll just accept everything as a default. This will take about a minute to get stood up. But the idea of the software factory operator is as an operator of operators. It actually orchestrates and helps pipe and helps integrate those underlying tool sets. So let's go ahead and look at this real quick. So we're up to speed. We've got the inside of my installed operators. You can see Plygos software factories in there. And I'm going to kick off a platform. We'll talk about platform in depth, but what this is doing when I kick this off is over the course of 8 to 10 minutes, it's going to go ahead and spin all the underlying other operators up, such as GitT, Nexus, SonarQube, and a couple others, and then start integrating those together, putting all the concerns such as role-based authorizations, surface accounts, and even going into the tools and adding specific, like in GitT or in SonarQube, adding organizations and getting that all piped together and ready. So let me go ahead and click off. It's as simple as just clicking create a platform. Now we're going to create a basic platform using Jenkins as our CI tool. I'll create that. If anybody's interested when they do this to watch it, you can go into your pods, look at your TSSC operator controller manager, hit the logs, and you'll start to see Ansible-based operator, and you'll start to see everything popping out there. Well, let's go ahead and we just kick the demo off. Let's get back to what this looks like. So Plygos. The traditional approach to something like a CI/CD pipeline or continuous or an integration type tool, so you have something like Jenkins in the middle that has the imperative logic for how it understands how to implement the workflow and invoke the underlying tool sets, whether it's static scanning, pushing to an artifact repo, or kicking off continuous deployment. What we've done with Plygos is we actually put Plygos as a layer. It's a business workflow layer that you stick in between your CI tools and the other things it invokes. What it does, it allows you to bring in that imperative logic into one place as a plugin structure. And then what happens is it redefines how the actual CI tool works to where the CI tool itself, instead of the CI tool having the imperative logic for how to kick off a static scan or how to push the artifact repo, it's all housed inside of Plygos and what we refer to as a step implementer. And it's in there, which brings about some very cool capabilities inside of a CI/CD pipeline at scale on a unified platform. So what are those things it brings about? Well, it allows us to unit test workflows. We can build workflows and we can unit test them by abstracting out the underlying dependencies, whether it's a static scanning tool or a Git repo. It allows us to integration test as well. So if you want to make sure your pipeline's running as well all the time, or you have a different change you want to bring to the pipeline, you can now integration test your pipelines from an end-to-end perspective, from a fully rationalized perspective to see how they operate. And then more specifically, it allows us to bring a workflow and a tool set as a purpose. It is abstracting out, it is removing some of those responsibilities of understanding the imperative logic from the CI tool. But by doing that, and even though we're adding one extra layer in there, what it's doing is it's giving us this flexibility for standifying and really doing CI/CD pipelines as code. So what is the tool and what does it consist of? We'll run through here in a deep dive, but really the tool itself is a CLI that depends upon two specific files for any type of software artifact, configuration file and a secrets file. This configuration file, what it looks like here, we'll walk you through, is you see different steps. These steps are generate metadata, tag source. If we were to go back and look at that workflow, these are the workflow steps. Now, how they're implemented, what is the imperative logic that implements it, is these underlying implementers, Maven, Git, on a tag source, Git, things unit testing Maven. The idea here is if you swap Maven out with something like NPM, you can still keep that same workflow, but now it's implemented for two different types of technologies, one for JavaScript, one for Java. Brings that simple way to manage these pipelines as you go forward. Here's an example of a Jenkins file. So for the folks on here who are familiar with Groovy and actually writing a bit in Jenkins, you know that you go into your steps and you write your Groovy or your Java basically inside of here. Now we're generating metadata with Maven. Notice here that there is nothing here invoking Maven. What we do is we just simply call an underlying CLI. We pass the configuration file and tell it to invoke the step generate metadata. And what it does is by invoking generate metadata, it will go run these step implementers, applying that logic, and then collecting the data from the input and the output and having that for a auditability perspective. So let's talk more specifically about Jenkins. So what does this look like in reality? Well, your source code repo right now, you'll have your app source and it has some CI/CD source. Inside your CI/CD source, there is a Jenkins file that is a proxy to another centrally controlled set of workflows. So this brings in a unique perspective. When we start talking about changing the rules, instead of having all the concerns around your CI/CD and how your software delivery operates inside of your source code repo, you can start externalizing that and having folks like such as a platform team responsible for defining workflow definitions, updating them, and maintaining workflow definitions. Same thing here is you can have security and compliance as code outside. We have a security officer or a compliance type officer contributing types of rules, whether OVAL rules or whatever the underlying rule set is, to how this workflow is, how security is codified in this workflow. They're not having to contribute to the actual underlying repo. So you're inheriting the software and feature teams inheriting these aspects from the organization. So inside here, you have the Jenkins file. We do have some abilities to validate the environment. Jenkins, the fun technology it is, sometimes you have to have certain things inside the repo, but as you bring Tecton or whatnot in the event-driven, with its event-driven approach, you can start to externalize almost all of the stuff to where what's just in your source code repo is the app source, and then on commit, all of this can get pulled in automatically and applied so the actual engineering team can focus on just feature engineering as opposed to all the other underlying aspects and concerns of that software delivery process. Plygos config secrets. So let's talk specifically about this. secrets, keeping your secrets secrets. So the idea behind here is we use Mozilla SOPs, and you can, if you're keeping secrets, if you're not using something like secrets management like Vault or what may be out there, you can encrypt your secrets and store them at rest inside of your Git repo using Mozilla SOPs. And so what Plyghost will do is it will pull it in, and once it sees an encrypted string, it will decrypt it, utilize that string, and then take care of the rest of the cleanup as necessary. So what the biggest capability Plyghost does is allow us to provide a self-service DevSecOps CI/CD capability. And we'll talk some more about this. Because what you can do here is by having this, you enforce behaviors with centralized and standardized processes and workflows. That's a lot for some not to understand, but I know there's always pushback, like, oh, we want the team to be able to make every decision possible. Well, that prevents scalability, and that's how organizations get caught up in scaling. Yes, this won't be a one pipeline to rule it all, but what it does is it creates a network of capabilities that an organization can use to deliver software to production. When we talk about self-service, what do I really mean about self-service? That's what we refer to as automated day 1, 2, and 3 operations. So let's dig deeper into this. If anybody is familiar with the DoD Enterprise DevSecOps reference design, I appreciate this document because it goes through and puts some very specific definitions around terms that are used fairly loosely in industry. So what is a software factory? They look at a software factory as an assembly plant that contains multiple pipelines. It's this single thing, like we just showed up here in OpenShift, that has multiple living instances of pipelines, or a single instance of a pipeline that has all of your that has the artifacts and everything for software deployments, and it supports a multi-tenancy approach. The CI/CD pipeline itself is a set of tools and associated workflow processes, and then you have a pipeline instance, which is a single instance of that workflow. So what is interesting is you have a CI/CD pipeline that could simply be like a Java Quarkus app, or a Java Spring Boot app, or a Golang gRPC API. But then you could have different instances of those, because you have maybe a customer gRPC API, and then you'll have a inventory gRPC API, where you have different instances for those specific sets of value that you deliver. Now, this is how you scale DevSecOps with the software factory. And actually, what if I say that, that's how you, using a software factory, is how you can scale DevSecOps. So as you think about things around here, like such as a base container or virtual image, you can go in, build it from trusted component bits and pieces, and then put that base container into another trusted repository or another network node. That's something like a Java app or an embedded piece of software, or a JavaScript container app can then pull those, whether it's a base container image or a virtual machine, and then use that to then build their software and deploy it to production. Notice it's a series of nodes and edges, not just one pipeline to rule it all. Each of those pipelines have a specific set of value. You'll have platform teams who focus on security aspects around those. So pipeline versus platform. What is the platform? It is that underlying tool set and services that integrate together and configure it for an organization's authentication and authorization. The pipeline itself is the implementation of a configured workflow that leverages the platform. We do recommend one pipeline per application. So if it's a Java app, it's a Java customer app, you have one pipeline there. If it's a container, a base container, say it's your organization's base container, you have one pipeline there. So it's different sets of pipeline instances, not one big pipeline for everything. When you look at this, let's talk about how we discuss this inside the flow framework. The platform itself is the tools network. The base container here, or the pipeline, is the artifact network, which then brings forward into the higher levels of the value stream network as this is all put together. So as you look at the software factory from here, these are how these components do play together in a very specified way. So getting back to software delivery is not linear, but it is a network. Your workflow is your value stream network. As you start looking at workflows, you're defining what that value stream looks like, how that value is defined, how it goes from input to output and values added over time. Your pipeline is the artifact network. It's the instantiation on top of the tool network, but it manages the artifacts and it manages the lifecycle of the artifacts as it goes through, and it applies and instantiates that value. And then your tool network is those underlying set of tools. Your TSSC platform is that tool network. So with that being said, let's go ahead and jump right back into the demo and show you what some of this. If I go back down here, it looks like play recap, we're completely done. It takes about 8 to 10 minutes to get up and going. But what does something like this look like? So if I go back into the installed operators, What you'll see here is everything that got stood up and piped together. Argo, Code-Ready Workspaces, Git, Mattermost. Here's something that's fun to look at. Let's look at the topology. What does this look like inside of your network once you've stood this up automatically? This is what it looks like here. I won't go into each of the specific tool sets, but things such as Selenium. So what the Software Factory did was stand this up. It stood up this this platform with tools, integrated them all together to be ready to add instances of pipelines. And so that's the power we're trying to get to from a push button approach, and why this is unique, and how this helps establish something like the approach to a flow framework. Let's get into the pipeline itself. So as I'll go and show you here real quickly, let's go into networking. We'll look at two different aspects. We'll look at Git, which is our Git repo, and then we'll also look at Jenkins here. So logging into Jenkins, go into here. What you'll see is it stood up with a basic organization and nothing inside of it. So we'll watch the magic happen in live time, and while some time passes, I'll go ahead and answer a couple questions. But here in Jenkins, if anybody's familiar with Jenkins, we still have a bit of an organization called Platform, and inside here there's nothing in Platform. Inside of Git, let's go ahead and log in. We're going to use a service account, but let me grab the secret for this service account. Go. It's just these service account credentials, so we can get some. There we go. So what you'll see here is we have, we go through here, there's nothing in the repository, just a very blank Git repository. Now we're going to add a pipeline. And a pipeline, again, remember, is applying that workflow, putting it on the set of tools, and then it's going to kick it off to start with. So you see your Jenkins and your Git. So we'll go ahead and go back into our operators, go into our stalled operators inside of our DevSecOps namespace. And this is such as a team, like if I need to create a new app, the whole use case behind this is an app instead of going to a platform team saying, hey, stand this all up. They have a self-service portal that can go in and say, hey, just create me an instance of a pipeline. And we're going to use a Quarkus reference app here. So this could be something such as a skeletonized app, or an app skeleton such as a Java or a Quarkus app or whatever it may be, with some attributes that could be customized. We're just going to take it as it is default. And I'm going to go ahead and click Create. And it's going to kick the pipeline when we get started, but what you're going to notice, and I'll do a little refresh, is this is going out to centralized repositories that we have on Plygos and other places, and pulling this in. So I talk about the RHEL, the Linux SKEL directory. If anybody is deep in Linux, you'll know that the SKEL directory is what's used, which is copied when a new user is added. So when a new user is added to a Linux machine, it goes up to the SKEL, it copies, because it's skeleton of what a user needs from the basic bits and pieces into their user profile, and that's where your user directory starts. Same thing is here. You can call them sample apps, base apps, whatever you have the name for it. But the concept's the same. Is you can have those standardized around, click a button, and then things just start happening automatically. So as we start talking about things getting pulled in, let's go to, notice we've just pulled in two things for the workflow standard here for Jenkins. It pulled in a full reference application. That's an API. That's just a simple Quarkus HTTP1 REST-based API. And then it also started kicking off workflows. Notice it added the app itself to the platform and kicked off the platform itself. We'll go into here, we'll look at this. And it started kicking off an actual run. So we'll look at the prettier index, the blue ocean, prettier view of it. But as we're going in, it's now just pulling in all the necessary assets to kick off the pipeline. But this is the idea. The idea is to be as simple as that, where a platform team goes in and operates almost like a product team internally, looking at what does the organization need from their standards, codifying those, defining those, and putting them in a standard place. You can click, you could basically click go and get started creating business value as soon as possible, while you're also being held to the standards and objectives of the organization from a centrally controlled manner and perspective. With that being said, that is a lot of the trusted software supply chain from very beginning to very end. You can also, if you want to check this out, feel free to go to github.com/Plygos. The software factory operator is where you can get started on bringing this in and looking at it. Always feel free to post up an issue or anything on there. We are looking for community contributors as well. So the ways to contribute are by adding other types of tools, such as like a GitLab reference, GitHub Actions, Azure DevOps, those types of things. The whole concept and idea we have is the more community contributions we can get, the easier it makes for people to pick and pull pieces and parts for them to build their own unified process. So it's really the community contributing to help the community at broad become better with delivering software and business value. With that being said, are there any questions that I can answer? I think there's 2 Q&As.
Yeah, so there's actually 2 questions for you, Bill. The first one is from James. Is there any roadmap for the project? If so, where can you find it?
James, yes, it's being posted. It's being posted publicly. So if you go to Plygos, there is a repo in there called Roadmap, and I'll show you on here. One thing you're gonna notice is just yet it's not in there, but we will be adding that in here shortly. Hopefully in the next week to 2, the Plygos roadmap, and we'll be getting it in here. What you'll actually be able to do is go in and look at in the project's perspective, the public roadmap, and you'll see the different quarters and the things that we're trying to achieve through there.
Okay.
I'm sorry, go ahead.
And then you have another one from Noel O'Connor. Does GitOps feature in this?
Absolutely. So Argo is used as our default. So we'll go back and look at this real quick. Argo is used as our default opinion, and GitOps is our default deployment opinion in here. So absolutely, you can swap out deployment opinions if you like, but we do feature Argo in here and a GitOps approach using a pull versus push type approach. Now, what happens in the background with the app is if we were to dig into some of the files, you'll see that there's a lot of Helm files and manifests that are just templated and codified out for Argo to utilize. But let me go, actually, as you're talking about that, let me get in here and see if I can, let me pull up Argo. Let's open via Shift. Let's do this real quick. So what you'll see is you can see you won't see an app in here just yet. I realized this morning, let's see if we fixed it. We actually have a compliance issue with our sample app if it's gotten that far. Yeah, our sample app had a compliance issue earlier, so we weren't getting, so it may not deploy here. But yeah, you can see Argo set up in here. What would happen automatically is when this deploys, it would be set up in here and managed from a GitOps perspective.
Okay, awesome. And then we have another one from James. How much does the default deployment of this tool consume on top of Kubernetes? And he's kind of, you can think in terms of measurements of cores or memory.
So right now, we don't have the apps up and running. If you look at cores, it's actively using about 2 cores and roughly, what is that, 8 gigs of memory at this point in time, just to get up and running. One thing to note about this and how it is set up, James, is that when we deploy, what you'll start to see is it'll deploy other types of projects in here in different namespaces. So any type of dev, test, and prod type environment that this deploys into is not under the DevSecOps namespace. It's under its own, in OpenShift, what would be called a project. It's under its own namespace and managed that way. But yeah, that's what you're looking about right now is what's being allocated there. Was at roughly 8 gigs, and it's using about 1.75 cores as it operates right now. Now, probably another question I'll ask before I'll try to answer before it gets is how much would this go up to? It would be as big as your organization gets, based upon the scalability of underlying tools, whether it's SonarQube or whatnot, whatever those requirements are. But just to get started, you are looking at about 8, 9, it's up to 9 now, but about 8 to 10 gigs of memory and 2 cores. At the least.
And I have a question a little bit more on the customer side of stuff. Is there any specific industries? Have you seen this implemented well? Like maybe the public sector versus like the financial services?
Yeah, actually both of those are sort of two specific targets for this. It started out of the public sector, so out of the U.S. Department of Defense, and I highly recommend anybody go read the DoD. They refer to as the DoD Enterprise DevSecOps Reference Design. Just for your own organization, I think you could just take the first page off, put your logo on it. It'd be a great reference for your organization on how to do DevSecOps. But yeah, this was initially geared towards helping DoD agencies and organizations what I refer to as color in between the lines of DevSecOps. So like this enterprise reference design is sort of a coloring book. It provides the outlines of what DevSecOps looks like for the DoD, but you still have to choose what mediums and colors to color it in with. And that's where the trusted software supply chain and what we're trying to do on the public sector side comes in. But even to that point on the financial or insurance or other types of highly regulated industries, in general, you want to have some, like you call it your reference architecture or your reference design, which is sort of those lines you color in between, but they're not going to be highly specific. And that's where something like the trusted software supply chain comes in with an opinion and approach to provide how you color in between those lines. So yeah, the more regulated your industry is, the more you'll benefit from something such as the trusted software supply chain and Plagos, because it was designed to have all of those other types of cross-cutting concerns, encryption, data collection, automated governance, built as a default in the backbone of it, not just as an add-on over time. Does that answer your question?
I totally see that. Yep, perfect. Yeah, and we don't have any questions, but we do have some comments. Or Noel O'Connor saying this is impressive work, and Arson Scratch is saying +1. So I think everyone is enjoying your presentation.
Great. Yeah, thank you all very much. This was a lot of fun. I love enjoying this because as I go through this, like I talk about my background, like as you put these things in place with the community and organizations, the idea is you give anybody the capability to build software at any time for any reason to experiment with any type of value. So always feel free to reach out, tag us up on GitHub, talk with us there. Feel free to reach out if you want to discuss more about this. Yeah, looking for community contributors and yeah, any feedback too. I appreciate everybody's the opportunity today and everybody's time.
Yeah, thank you so much again, Bill. Everyone, what I'll do is this way we can help Bill even more. Is I'll send you a link to the survey, and that way you can tell us like how helpful this meetup was, and this will help Bill make sure that he knows what to double down on going forward. All right, guys. Well, thank you so much, and hope you enjoy the rest of your day. Bye.